In this lecture, we are going to discuss about the next scheduling algorithm, which is priority scheduling algorithm. So, let us see how this priority scheduling algorithm works and the advantages and disadvantages of this priority scheduling algorithm. This is a good algorithm and we'll see the advantages and if it has any disadvantages and how it can be solved. So, let's get started. So, scheduling, what happens in scheduling is that a priority is associated with each process and CPU is allocated to the process with the highest priority. So from the name itself we can try to understand that in priority scheduling what happens is that each process is having a particular priority and based on their priority the schedule will take place. So the process that has the highest priority will be given the CPU first and then the process which has the next priority will be given the CPU next and so on. And if we have two or more processes with equal priority, then that will be scheduled in the FCFS order, which is the first come first serve scheduling order. So if there are two or more processes having the same priority, then the process that arrived first among them will be given the CPU first. So that is how priority scheduling takes place. So here in this we will study about shortest job first for scheduling, and here we can define the shortest job scheduling in terms of priority scheduling like this. And this algorithm is simply a priority algorithm where the priority is the inverse of the predicted next CPU burst time. The larger the CPU burst, the lower the priority and vice versa. So the shortest job for scheduling is also basically just a priority scheduling where the priority is determined by the next CPU burst. So we have seen that in the shortest job for scheduling, the process with the smallest next CPU burst time will be first to get the CPU. And so we can say that the next CPU burst or the predicted next CPU burst is the factor that determines the priority of this scheduling algorithm. So what we mean by the sentence here, the priority is the inversion of the predicted next CPU burst. Why we say this is because the larger the CPU burst, when the CPU burst is large, then the priority is slow because the process having the shortest CPU burst will be the first one to get the CPU. So that the process will be of higher priority. So the larger the CPU burst, the lower the priority, the smaller the CPU burst, the higher the priority. So that is what we mean by this sentence here, where the priority is the inverse of the predicted next CPU burst. So this algorithm also is simply a priority algorithm with this factor. So the practice scheduling can either be preemptive or non-preemptive. So that we talked about a lot about preemptive and non-preemptive scheduling and we know what it means. So priority scheduling can either be preemptive or non-preemptive. So let's see what it happens when it is preemptive and when it is non-preemptive. So what happens in a preemptive priority scheduling is that a preemptive priority scheduling algorithm will preempt the CPU if the priority of the newly arrived process is higher than the priority of the currently running process. So what happens is that we are following a preemptive priority scheduling. Then if the newly arrived process has a higher priority as compared to the process that is currently executing in the CPU, then the CPU will be taken away from that currently executing process and be given to the newly arrived process with higher priority. So that is what we mean by preemptive priority scheduling, and that is what happens in that. Now what about non-preemptive priority scheduling is? Non-preemptive priority scheduling, what happens is in non-preemptive priority scheduling, the algorithm, it will simply put the new process at the head of the ready queue. So if you are following a non-preemptive priority scheduling, then if a new process arrives with higher priority than the one which is currently executing, even then the currently executing or running process will not be disturbed, but the newly arrived process will be just kept at the head of the ready queue. That means it will just be kept in the queue according to its priority. So if it is having the highest priority among all the other processes in the queue, then it will be kept at the head of the queue, and then when the currently executing process completes this execution, then the newly arrived process will be given the CPU for this execution after that. So that is what it happens in a non-preemptive priority scheduling.